This talk is about 2 hours long, so we're going to cover a lot of ground. If you have questions, let's do it as we go, so that we can make sure that those get addressed. Is that making too much noise? Today we're going to talk about a lot of things. All the deliverables that WinSE does. I think Dennis talked a little bit about that, but we're going to elaborate just a little bit more. What's in a service pack? Perfect. Is that better? Okay. Who the service packs go to, how many service packs we've done till now, what the goals are of a service pack, what the different phases are of a service pack, who the service pack partner components are, what is a service pack war room, what do we do there, what is the bug process for service packs, and how do we decide when a service pack is ready to leave. So all these are basically pieces of a service pack. We have hot fixes that get escalated through CPR. We get crit sits, which are critical situation hot fixes, which are basically when a customer is, can't work, and so we have to work 24/7 to get it out the door. So it's basically a hot fix. It just has to get done a little faster. Then we have the security patches. These usually go to Windows Update and get released publicly with a bulletin. And we have general distribution releases, which are also going to Windows Update to the public, but they're not security issues. And that would be like a JET service pack or maybe a legal issue or something like that, where it still covers everybody, but it's not a security issue. Then we also have redis, which are when a company decides that they want to redistribute a hotfix. So they have to go through permission, and basically it gets tested just like something that's going to the web, because we can't control who those go to, like a hotfix. Then we also have security roll-up packages. Now, the security patches are usually just one fix for one issue. A roll-up package might be many fixes for one component, or maybe many fixes for several components all lumped up into one package. And this is nice for customers because they only have to deploy one package. Then we have service packs, and all those other things are rolled up into the service pack. Like I said, those are all part of the service pack. Customer fixes come in through CPR or PSS, which are both product support avenues. And then we have the Watson error reporting and the internal deployment, which they just changed their name to Microsoft Information Technology. So they're now the MIT group instead of OTG. I think they changed their name more often than any other team on campus. And basically they support all of us internally with security patches and all kinds of fixes just to keep everybody up to a certain standard. And security fixes can come two ways. They can be publicly known, and in those cases we would most likely issue a bulletin and a public patch. And then we also have ones that are found internally, and we usually only take the really critical ones on those. Oh, and one of the other customers could be an internal team that's not part of Windows, like BizTalk or SBS, Small Business Server, or one of those teams. They'll come to us and ask us for a hotfix that'll work on Windows for their component to work correctly. Let's see. I also have Okay. So these self-host deployment fixes are bugs filed by people internally that are self-hosting on the service pack. And those will get, I mean, they're just treated like, kind of like a beta customer. And then stress fixes are run by the test team, and they hit those all the time. So we're constantly fixing those because those are pretty much test blockers. And regression fixes, anything that used to work now doesn't work, those need to get fixed. And that could be from a previous service pack or OS release or within that service pack itself, because we don't want to ship with any regressions. The other proactive fixes are just nice to have things. Developers are pretty good about wanting to get things, even across the board. So sometimes they'll want to do things, backport it to the service pack from the OS higher. And if they foresee an issue that customers might complain about, they'll want to fix that as well. And then we have the design change requests, which are like features that change. And we don't really like to take those, but we do. And some service packs have a lot more than others. But they go through their own process to get approved, which is a lot more complicated than most other bugs. And then, like I said, that sometimes they'll want to do backports, which are mostly proactive. But forward ports are really necessary because you don't want to regress somebody that's migrating. So that supports the migrating case. Any questions so far? Okay, so service packs are for all the client OSs and all the server OSs. And that includes all the different kinds of users that you see there. And that one's pretty self-explanatory. And the places that we distribute the service packs to are Microsoft.com, Windows Update. We give media to the OEMs for pre-installation. We do corporate rollouts internally, and other corporations do rollouts, deployments to their internal networks. And then we also have retail channel. And there's different kinds of packages that go to those different places that they'll elaborate on the next couple days. So far, we've released quite a few service packs. Windows NT 4 had 7, and Windows 2000, we just released SP4 last summer. And Windows XP, we're working on SP2 now. And for server, we're working on SP1 now. So, the goals of a service pack are obviously to deliver a very high quality, stable product to our customers. And we want to minimize the code churn. That's why we don't really like the DCRs, and only take the critical proactive fixes. But we want to fix as many customer issues as possible. And we don't want to ship with any security issues. So it comes down to RTM time. It's pretty tight because we don't want to have a patch going out right afterwards. And we certainly don't want to ship with any regressions. So, different parts of service pack lifecycle. Start out with planning. Basically, we identify all those key areas, mark the bugs appropriately. Then we define our bug bar or acceptance criteria so that you can triage bugs accordingly. We review the bug counts, and we kind of bucketize them into all those different areas up above, so that we know where we are in the project, and if we can meet our milestones and our deadlines. And then we try and put together a schedule based on all that information, and knowing that it takes so long for a test pass before each milestone, so long for an escrow period, and the release part of it. And then we also have our the GDR testing that takes a couple of weeks out of every month or so. And basically everyone shuts down service pack work and does this testing on the GDRs. So we kind of have to factor that into the service pack schedule. And I think Jamie Blair will talk more about that GDR process in the next couple of days. We have the proactive phase, which for WinSE KSP5 is probably right now. It's basically when the bar is at the lowest it's going to be, and that's when they can get in the nice-to-haves and all those, along with everything else that's going in already. There's a DCR process. Basically, the team that wants to do the change will have to come in, and they get grilled with all these questions, and everybody needs to agree that that's the right thing to do, and that it will be serviced for the life of that service pack, and that the owners are established and everything else. And so we pretty much lock down the DCRs towards the, well, probably about beta time frame, because we don't want to really get the code churn after that. And then we lock down on the proactive fixes and the critical fixes as well, the internally found critical fixes. We take the externally found security ones, like I said, until almost towards the end. And we also take customer hot fixes until very close to the end as well, because we want to make sure that we get as many in as we can. So, the beta phase is the first major milestone, and in this phase, we basically decide when the build is of a certain quality that I'm sure the testers, gosh, I can't remember who the test person are. There's several I know that will hit this, talking about regression testing more deeply in the next couple days. But basically there's some criteria to meet before we can hit that point. So once we hit that point, clock starts, we run that test pass, and during that test pass, we're also running stress. Everybody participates in that in one degree or another. Everybody also self-hosts, which means you run it on your main machine with your mail and everything. It's a risk sometimes, but everybody does it. And then when we're comfortable enough, we declare the minimum build for sign-off, which means now some components have a very lengthy test pass, and some have a shorter one. So when we declare that, that's like when we hit the long pole for the person or the components that take the longest. And then within that time, everybody just keeps running their tests over and over again. Now, an escrow blocking bug would be one that would reset all the major components. And there's this a defined list of who the escrow resetting components are. So when a bug comes up in those areas, you really have to dig into them and figure out if you really want to reset escrow and your schedule and everything else to take it. Yes? Yes? Okay. So, the question was explaining what the term escrow means. And basically, as I said, It's the period right before RTM where we don't want to touch any code that we don't have to. Now, an escrow component would be something like networking or and all the binaries that are included in that. And if a bug comes up and it's in that binary, then we have to decide, are we going to reset everybody's testing because that binary or that component affects everybody, or can it wait until RC, the next phase, or we take it at all? Does that answer the question about the? Yes. Every major milestone has an escrow period. And of course the bar is higher as you get closer to RTM. So the escrow build is when you say, okay, this is the build. We don't have any more bugs in any escrow resetting areas. And those are marked in a certain way so that we can track those. And then when we get to that point where we don't have any more, then we declare that the escrow build. And then from then on until that milestone ships, in this case the beta, it will, day by day you just look at bugs and you say, okay, does this reset escrow? And you just have to look at every single one. And that's why we look at all the different reports in the war room, so we're sure not to miss anything, let it fall through the cracks. Because if you're going to reset escrow, it resets everybody's tests. And for those teams that have the 4-week test passes, that basically is going to change the schedule. Once that escrow build is established, then that goes to some OEMs or JDP customers, which are now called TAP, I think. And those are basically some customers that have agreed to deploy the beta in their environments. And so we let that go for about a week, and if there are no escrow resets, then OTG will deploy it internally. And then we're getting closer. And then the release team locks down all the release notes and the bug fix list. Now for beta, the bug fix list consists of all the QFEs that are in the service pack to date. And it's basically just a KB article with a link to all those KB articles. And the rel notes is short for release notes, which is things that the beta customers are going to see. We don't want to get a lot of churn in the news groups and bugs filed. We are going to fix it, but we haven't fixed it for the beta, so we just let them know about it. And if there's a workaround, give them the workaround or whatever, and then they just know that it'll be fixed in the next milestone. And then we get to the ZDR process, which we do release media to some customers for the beta. And the ZDR process is basically not that much big of a deal for beta, but because it's basically a part of the build process that makes it special for that SKU. So if it's the OEM SKU, it'll put in that special PID and that special time bomb and that special thing that makes that the OEM SKU. There are 4 different SKUs: volume licensing, OEM, MSDN, TechNet, and retail. But like I said, for beta, we just do OEM and retail, I think. And let's see. Then we get the tests to verify the media and sign off, and everybody and all the test teams sign off, and we have a formal sign-off tool. And then people can make notes of bugs and things that in there that they want to get fixed for the next milestone if it was kind of critical to their component. And then it goes up to beta place or Windows beta, depending on which product it is. And it goes out to all the beta customers. I'm trying to remember. For SP4, I think we had a gosh, about 5,000 beta customers all over the world. And then somebody monitors the beta bugs, and they'll report in WAR and to let us know what the top beta issues are. And usually it takes them a while to deploy. Some are very anxious, and some take a little while. There's usually a lot of activity in the news groups. There's somebody handling those issues as well. And they also report to the WAR team and let us know what's going on in there. Basically, there's not too much difference in the RC phase and in the beta phase, except that let's see, I think about the only difference is the bug bar, because as we get further towards RTM, the criteria gets higher. But pretty much everything else is the same. Now, the release candidate is, we can have more than one. And the reason that we want to call it RC1 and RC2 is because some companies have licenses that say that they can only deploy a release candidate, not a beta. So we'll get a lot more customers for the RCs. So that's why we have RC1 and RC2 sometimes. And then the RTM phase has a few extra things thrown in. And basically, we have RC out there, and we refresh every time we hit a build that we feel is good. And usually we try and do this about every 2 weeks or so. And that just gives us a little bit extra testing effort and coverage and feedback. But, the closer we get to RTM, the less time we have for people to have time to deploy it and get the feedback. So we try and get it out as soon as we can. The other thing that's different about RTM than the other previous milestones is that for RTM we have all the documentation going in, and it's all localized for RTM. It's all English for beta and for RC. So that happens pretty soon after the last RC, because all the loc teams have to do all their work, and you have to lock down the documentation, because I can't remember how long it takes, but if we make a change to something, it takes a while to get it localized again. So that gets locked down, and then let's see, we still have the regression pass, and then the other thing is, I forgot to mention this in the other milestones. For every milestone, we do a code fork. Now what this is basically is we get to the point, which is usually maybe a couple weeks before RTM, and we basically cut the branch or fork the branch off so that you have one branch that's going to be your beta or your RC, and then you have the other branch that's going to keep taking fixes. So basically you're just cutting it off and saying, okay, this is it. And then if a security issue were to come or something, then we would definitely put it into that branch. But basically, from then on, all the fixes go into this main branch. And then the beta or RC branch is then used to support the JDP and OTG internal customers. If we were to release a security patch, everybody has to get patched, so we'd have to build a patch off of that branch. And then that would only be for that one build, and that would go out internally into the JDP customers. And then, so all the hot fixes get built from the main branch and everything else. And then for RTM, when we fork, it's forking for the next service pack. So at that point, all the hot fixes and everything go into that branch from then on. And the only things that you're going to take into your RTM build are the last few bugs that you have to get in. And Jack will be talking a lot more about the branching and the build process. Yes?
So this regression is on 3 times? 4 weeks of regression in each of the 3 phases?
Yes, I think for RTM they do it twice. Oh, I'm sorry. The question was, do they do the 4-week regression test pass for every milestone? And the answer is yes, and I believe RTM, they do it a couple times. Yeah, they run the regression pass, and then and then a 2-week pass after that. Usually the regression test pass starts a little before escrow, and so people like to reset a couple of their test passes to once we declare escrow. But like AppCompat is one of the long pole teams that, they have hundreds of apps that they test. So once they start their pass, it just keeps going and going and going. And if we slip the schedule, they just keep going and keep doing, they start at the tier whatever one and go down from there. Yes?
What's the timeline between beta to RTM? How long does it typically?
The question was, what's the timeline between beta and RTM? Basically, it depends on the number of bugs, honestly. And we try and, when we do that initial planning, we try and say, when we hit the certain number of bugs is when we'll be ready to do beta. And then when we hit this, subset of that, we'll be ready for RC, and then down below that. I think it kind of depends on the OS as far as the number of bugs and where they're at and stuff. But it's usually pretty much run by the number of bugs. And, there comes a time where the bug bar changes and, certain bugs don't meet the bar anymore and you have to re-triage. And everybody fights, for certain things. And sometimes they get them and sometimes they don't. But, like I said before, we always fix regressions. So if things get introduced and things pop up at the last minute, you have to fix that regression. You don't want to ship with it. So even if it's just the beta. We have partner teams that have components that ship with the OS, and there are several of them, and these are just a few examples. And the partner process varies depending on the component. Some teams have their own SE teams, so they do their own hotfixes and their own security patches and crit-sits and everything else. And then at a certain point in the service pack process, they just, before each milestone, they just kind of sync up. So they just check in all their QFEs and stuff out of their branch so that the service pack is in sync with everything that they've released. For other components, we have their source, and they use our database, and we do all their hotfixes and all their security patches and everything. So it just depends on what the component is and how they started out from the beginning of either when the OS RTM'd, or in some examples we take some partners in as a DCR into a service pack. And then from then on, we service them. Okay, so the WAR meetings are really, the content of what goes on in them is really based on what's going on in the cycle. When we get, when we're doing the planning phase, we talk a lot about what the bug criteria should be, and what DCRs we want to review, and then things like that in the beginning. And then we start, like I said, we bucketize all the different types of bugs into different reports, and we look at those based on, at a certain point, we'll stop taking the proactive fixes, for example. So at that point, that report goes away. So anything on that is either won't fix or, hopefully we don't punt anything to the next service pack, but sometimes that happens. So as we get closer to RTM, the bar gets higher, so those bugs just need to go somewhere. Usually it won't fix because the policy is, if it isn't worth fixing now, then it's not worth fixing later. And of course, with every subsequent service pack, the bug bar is higher anyway. So basically, we just stepped through those reports. We also talk about the self-host report. All the leads are in the meeting, so we'll talk about, who's a slacker and not doing their self-host responsibilities. And same with stress, who's running stress and what are the numbers and are we getting, because the release criteria for each milestone says that we need to have so many people running stress and so many people running self-host. And long-haul stress has to be running for a certain amount of time. And all that stuff is established in the planning phase, and then we just review it in WAR. And build also provides a status report of how the build is doing. If there's a build break, that's pretty much 24/7 type of thing. So it usually is fixed by the time the next WAR meeting is. But they talk about when the next window is going to close. If there's some issues with some of the languages or something like that, then we'll release a build for only some languages, not the ones that were broken. And they'll provide status on what needs to happen to fix that. So, basic bugs, not the ones that come in from CPR or security ones, are found by the testers, and the tester will reproduce it and ensure that it persists, and then they'll show the developer their repro, and he'll debug the issue, and then he'll create a private fix, and then the tester will verify that private, and then the tester will also review the changes, and between the tester and the developer, they'll decide whether that's the right fix for that area and that problem. And then when the tester decides that it's good, then they'll, I think they mark the bug with a test template and show the work that they did on it. And then the developer does the same thing, and he provides a template. And then they bring it to WAR for approval, and it's usually the tester that does that. And basically they just explain the problem and the fix, and then the WAR team decides if that's the right thing to do and approves the bug. So, a service pack is ready to go when we have no more active bugs. And like I said, there comes a point where you start, marking them, resolving them won't fix, and some of them do get punted off until the next service pack because there's something that has to be done but just can't get done in that time frame. And then there are no resolved bugs. Basically, when we get to the end of each milestone, there's the test leads, I think, pretty much pound on the testers to make sure that all the bugs get closed against that milestone. And there are no bugs in the international space, no loc bugs. And we also get some international bugs that are actually code fixes, and then that affects every language. But a true loc issue could only affect maybe one language, or maybe the Far East languages or something like that. No deployment blockers, which is basically signed off when the JDPs and OTG say it's good to go as far as deployment. And then we have some of the release criteria there, 95% for self-host and stress. and then at least 2 weeks of the long-haul deployment. So basically, OTG and some JDPs and Premier customers have run it for a couple of weeks and have found no issues. We don't have any regression bugs that we know of. And all the MSRC issues that were ready to ship are in. And those go through a lot more testing. So, you know, we could have a brand new issue and we might ship with the known issue at the very beginning phase, but it would be, you know, a couple of months before it got released. So that might be okay, depending on the timing. And then all the different component owners sign off on their tests, and release signs off on all their pieces, documentation, the ZDR, all the media, all the they do download testing from the different download locations, and then we also get sign off from some of the customers that have deployed early, and then we sit on it for a few days and just make sure that it's ready to go. And we always give out prizes for the person that finds that last bug that gets fixed. Any questions? That was a lot of stuff. You guys must be tired. So, like I said, in the next couple of days, there's a bunch of presentations by people that are going to elaborate on a lot of the things I talked about. The security issues, the hot fixes, build, the forking, and test will cover the escrow and regression testing, all that different stuff too. Yes? The 4 different SKUs. The question was, what were the 4 different SKUs of media? There were the OEM, volume licensing, MSDN / TechNet, and retail. Basically PIDs, time bombs, licensing stuff. Now, as far as the types of builds we have, which Jack will talk about as well, some of the media has what we call slipstream or integrated, which means that the service pack is integrated into the OS. So basically, you have a CD that's the complete OS with all the service pack changes in it, and that comes in the Pro and Server SKUs. And then we also have what we call the upgrade, which is basically you have to have the OS with N-1, and then you can install on top of that and get upgraded with the latest service pack. And then the other flavor, which doesn't go on the media, is the patch, which is for Windows Update, and basically that's will only give you the delta. So basically, if you are a very good user and you go up to Windows Update all the time and you download all the patches and even the recommended things and even have a few hot fixes on there, then your delta would be a lot smaller, and therefore your download time would be a lot smaller. So those are the 3 different types of packages that we build. And the 2 first ones go on the media. And so it just depends on the who's getting that media, what flavor it is. Did I hit on all those questions that you gave me? Yeah? Okay. No questions? Wow, that was supposed to take 2 hours. I just whizzed right through it.